Welcome. In this particular video, we'll be solving trigonometric equations involving cosine part 4. Let's take a look at our first example. Solve the equation given below for theta greater than or equal to 0 less than 2 pi. Notice that the particular equation we're provided is already solved for cosine. So the next thing we want to do is to figure out what is the period of this function on the right hand side. So recall that the period for cosine is 2 pi, so we take the 2 pi and we're going to divide that by the absolute value of the coefficient of theta, in this case 2. We know that the absolute value of 2 is equal to 2, so we have 2 pi divided by 2, which is equal to pi. So the period of this particular function on the right hand side is equal to pi. Now once we have the period, let's go ahead and introduce a new variable alpha. So let alpha be equal to 2 theta plus 2 pi over 3. That way, we can rewrite the original equation as follows. Negative 1/2 is equal to cosine of alpha. Now, we're looking for the angles that have a corresponding x-coordinate equal to negative 1/2. So we're going to make use of the unit circle to figure out what are those angles. In this particular case, we start at the origin and we're going to go to the left because x is negative, and we're going to figure out what are the angles that have an x-coordinate equal to negative 1/2. So notice the corresponding angle here is 2 pi over 3, so we have that alpha could be equal to 2 pi over 3, and if we were to reflect this point across the x-axis, we get the other value that actually has an x-coordinate of negative 1/2, and the particular angle corresponding to that is 4 pi over 3. Now, using those two values, we're going to solve for theta. So using the first value of alpha, so alpha being equal to 2 pi over 3, solve for theta. Now, in this case, we know that alpha was defined to be 2 theta plus 2 pi over 3. So let's replace alpha with that particular expression. So we have alpha instead is 2 theta plus 2 pi over 3. And that is equal to the right hand side, which is 2 pi over 3. Now, in order to solve for theta, let's go ahead and subtract the 2 pi over 3 from both sides. If you notice, this will cancel, and so will this. So we get that 2 theta is equal to 0. So let's divide by 2 on both sides, and we get that theta is equal to 0. So that's our first angle. Now, to get the other angle, what we're going to do is to take that 0 and add the period to it. So the period we said was pi, so we have 0 plus pi, that is equal to pi. So that's our next angle. And both of these values are solutions using that first value for alpha. So let's go ahead and take the second value of 4 pi over 3 for alpha, and let's solve for theta. So let's write the following. Using alpha is equal to 4 pi over 3, solve for theta. Now recall again that theta or alpha in terms of theta is the following. We have 2 theta plus 2 pi over 3 is equal to 4 pi over 3. Now to get theta by itself, let's go ahead and subtract the 2 pi over 3 from both sides of the equation. And we get that 2 times theta is equal to 4 pi minus 2 pi, all of it over 3, so that is 2 pi over 3. Let's divide by 2 on both sides to get the theta by itself. And we notice that the 2's cancel here and so in here. So we get that theta is equal to pi over 3. So that is another solution for us. Now to figure out the other solution, we take theta to be pi over 3 plus the period of the function, which we said was pi. Now let's multiply this pi by 3 over 3 to get the common denominator. And we get 1 pi plus 3 pi becomes 4 pi, all of it over 3. So that's our next solution. So combining all the solutions, we can say that theta is equal to 0, pi, pi over 3, and 4 pi over 3. And those are the solutions to our original equation. So this concludes this particular video. Thank you for watching and have a wonderful day.